Okay. So first of all, what is a trie? So I hope you remember about what is tree. So initially we know that in case of a tree, there are multiple types of tree, right? We started with a binary tree where we have two childs. So this was the parent, and then we have two childs. This was the left child, and then this was the right child, correct? So this was the binary tree that we have. Now here, why it is called binary tree? Because it have two childs, okay? Because it have two childs. Now there could be a tree which have k childs, okay? So it is called k array tree, okay? So simple, this is a tree, right? Now it could have k childs or n childs, whatever you can say. If it have three child, right, it is called the ternary tree, okay? It have four child, so it keeps on increasing, right? So in general term we can say it's a k child tree or k array tree, okay? So this is the general term, k array tree, when any node can have k childs, okay? So we call k array tree. So trie is basically using the same concept here. For each node there could be multiple childs, okay? There could be multiple childs. Now the next question comes, why and where we use childs, okay? So first let me explain you what is a k array tree, right? So consider you are storing some string like a b c, okay? Now the first node could be a, okay? The second node could be b, and the third node could be c. Simple, right? So you start storing. Now if you want to store after abc, if you want to store a and d, that is and, okay? And you start with the root, you see, okay, and already exists. So what you will do, you will store n after it, okay? And after n you will store d here, okay? Now someone asks you to store answer in the same tree, okay? So you again start with a tree node for storing that answer, okay? First character is same, that is aa, so you will move on to the next character. Next character, matching character n exists, okay? So you move on to the next character. Now in the next level s doesn't exist, right? So add s here in the next level after n, okay? And then there is no other exists, right? So w, e, and r. Simple, right? So this is a simple trie that we form, okay? So what is a trie now? Just a minute. So if we talk about what is a trie, so trie is simply a k array tree, okay? A simply k array tree which have k child. First of all, this is the basic definition of trie, that is it is a k array tree, right? Now what is the use of trie? So trie is basically used to store and search some specific key from a set, okay? So consider multiple keys are given like a b c, okay? And then and is given to you, and then answer is given to you, right? So these are the multiple keys given to you. Now the concept of trie is to store all of them, okay, in some data structure, and then retrieve it or search it whether they exist or not exist in the that data structure, right? So that is the basic use of trie, okay? Now it's a kind of a multi-level tree structures where we have a multiple level, like we started with this level, right? Then we went to this level, then we went to this level, right? So depending upon the tree that is given to it, depending upon the array that is given to us, right? Depending upon these strings, we decide the number of levels in the trie, or you can say simple k array tree. If you it seems difficult for you to say trie, then you can assume that k array tree, okay? Okay. Now, what is the use of trie? Okay. So when there is a large amount of strings given, okay, then we use trie to store all of them, right? Simply see here to store A, B, C, A, and D and answer, right? So what we did, we checked for the first level if the first level, if the variable is same, right? The character is same, A, right? So we haven't stored it multiple times. We stored it only once, right? So whenever we want to search for and, right? So what we do, we start with the root, we go to A, then we go to N, then we go to D, right? So simply we search for and here, simple, right? But we save the space also here because besides storing and multiple times, we store it only once. Besides storing this A character multiple times, we store it, I think, one time, right? Here, if you see that one AN and AN is repeated in these two strings, right? So besides storing AN multiple times, what we did, we store it in only one node, okay? Only one node will be used for this AN, simple, right? So what is the use of trie if we would talk about? So it's kind of used to store the strings, right? It is used to store the strings, okay? And retrieve also. And at the same time, retrieve or search, we can say, right? When there is a lot of strings given to you, okay, and you want to apply some data structure, so to store it in a very good format, right? So we use trie. Once we see the problem statement, once we see when it is used, so you will be able to understand what is the use of trie, okay? Simple. So consider, basically it is used for the pattern matching. Consider the name abc is given, a and d is given, answer is given, right? And someone asks you, someone comes here, right? Consider this is the dictionary, right? Consider this is the dictionary that you are building, right? In which there are multiple words. Consider a lot, right? Answer, right? And then are, right? Then bad, then bad, whatever, right? Multiple words are there in this try. Simple, right? Now, in this dictionary, someone asked you whether this some word, they gave you some word called bad, right? And they ask you whether this exists in this dictionary or not. Okay. So the first thing is to go through all the words, right? And start matching the character. So for bad, we match first character, doesn't match, we go to the next one. Okay. So if characters started matching, then we can start comparing that complete string. Okay. And otherwise, we check for the another string. So that is what we do in a simple approach, right? But in case of a try, we start from the first level itself and we get to know whether that string exists or not. Okay. So this is basically used for the pattern matching. This is basically used for the pattern matching here. Simple, right? Now, when we have to match multiple patterns like a lot, answer, are, bad, bad, right? So this is used for the pattern matching. Here we have a prefix. What is called prefix? So we understood two terms, right? What is prefix? What is suffix? Okay. So in prefix, basically we have the starting. We talk about starting like a lot, answer. These are the prefix of these strings, right? Suffix is the last terms, like combining the last terms we form. So that is called the suffix. Simple. Now, if we want to basically these strings, if we see these strings like abc and answer, right? So in these strings, some of the prefixes are common, right? So here a is common in all the three. Here an is common in all the two, right? So prefix is common, so we actually utilize that. We actually utilize that logic, that if prefix is common, then why to store it extra, right? Why to assign one more character? If it's common, we can store it only once and we get to know, okay, if the answer word is there, so we start with a, we go to n, S, W, E, R. So all of those words should be there in the string, right? In this try, right? Okay. So let me tell you how we are going to form the try. Simple. Okay. So consider we have simple strings are given to you. Okay. Some simple strings are given to you like answer. Okay. Like and anything, right? So let's try. Some strings are given to you. Consider answer and Arpit, do, okay, or die, okay, and study. Something like this is given to you. Okay. Now you started creating a try data structures, right? So try data structure you started creating. Okay. So you started with the first string. Okay. So consider this is the root to you. This is root. Now this could have 626 alphabets below it, right? Because how many alphabets are possible? 26, right? So we start with this. We first try to insert answer. Okay. So the first node in the answer will be a. The second node in answer will be n. The third node in answer will be s. So we stored the first one, that is answer here. Okay. Then again we start storing and. Okay. Now for and we check in the root whether a exists. The child of a, the child of root is a, the initial node. Yes, a exists. Then we check for a, does n exist? Yes, n exists. Then for n we check, does the child d exist? No, child d doesn't exist, right? So if child d doesn't exist, so we have to add the child d. Okay. And update two things here. This is EOD, like end of, this is end of string. So one of the string is getting ended here. Simple, right? So answer is the one string. Here also one of the string is getting ended. So A and D, A and D is one of the string, right? Simple. So EV mark, E is basically, that is, it is getting the end of string. Simple. Okay. Now let's walk through the next one. A. So we check for the root. Does A is the child? Yes, A is the child. We check for the root for A because whether R is the child? No, R is not the child. So we'll add R here. Simple. Now for R, we check P is the child. No, for R, there is no child called P. So we add P here. For P, do we have a child called I? No, we don't have any child called I. So we add I. For I, do we have any child called T? No, we don't have. So we update it. Now, whatever string, when we try, we completely inserted the string, we update the end of the string is true. End of file or end of string is true. So it means that one of the string is getting ended here. Simple. Okay. Let's try to add the new one. Do. So for D root, we check whether D exists. The first character exists. No, first character doesn't exist. Okay. So let's add first character D here. For D, we have O? No, we don't have O. So let's add O here. Okay. And we update, this is the end of the string. Simple. Okay. Let's see now. Now for die, we check for the root, D exists. Yes. I exist after D. No, I doesn't exist. So this should be I. E exists after this. No, E doesn't exist. So E we will add. Simple. Now for a study, we check for the root. Does this have a study S? No, doesn't have a S. So let's add S. Now simply for S, and then we add T, then U, then D, then Y, right? So these are the end of files. This is also end of string. This is also end of string. Now, so this is the case. How do we do the insertion? Simple. This is like how we do the insertion. So to add any string in this, because the size of the string is consider n, right? So to add any string, how much time it will take, right? So to add any normal string, it will take big O of n time. Simple, right? Because we have to add it to all the go through all the checks, right? So it will take big O of n to add any string, okay, or any character of that string. Simple. Okay. Now, how do we do the searching? Okay. If someone comes here, okay, if someone comes here and asks whether this dot would exist or not, we will see. Okay, let me check. Okay, then we will go, or simply let's start with first one. Will someone ask like and exist, and then someone ask and exist, okay, and then someone check dot exist. Okay, so this is the searching terms we are doing here. Okay, simple. We started with and. Okay, so let's go through from root. For root, let's check whether A exists. Yes. Now next character is N. So for A, do we check that N is the child? Yes, N exists. D, for N, we check that D is a child. Yes, D is a child. So it means that we have all the characters, but one thing needs to be checked, whether this is the end of the string or not, whether end of the string is there or not. Because if end of the string is not there, there might be possible we are trying to add Andaman or something, right? Andaman, right? So Andaman means D will not be end, right? So and will not be existing, right? So end of the file should be there. So we check yes. For the D, we have the end of the file or end of the string. It means that and exist. Okay. So this exists. Okay. Now for and, check from the starting. A exists? Yes. Okay. N exists? Yes. Do we have a child T here? No, we don't have a child T. It means that we are not able to check the complete string. It means that this doesn't exist. Okay. So every time here we have to check if we are able to cover the complete string, right? So we have to also check if end of file is equal to or end of string is equal to true, then only we say that this exists. Okay. Now for dot, okay, so we started with D. We see that okay, for the root D exists. Then for D, O exists. Yes, O exists. Okay, simple. Now again we check for D, right? So there is no child of O which is D, so we are not able to find the answer. Simple, right? So dot doesn't exist. Okay. Now, okay, let me give you another problem and let's see. Now try to draw the trie structure, this trie. Okay, similarly what we have done, right? So how we are inserting, we pick the first character A, we check for the root whether A exists or not. Exists, then move on to the next one. If it doesn't exist, then add it. Okay, then similarly for N, we check. Similarly for if you talk about like we are trying to add and, right? So before and, we have already added this, so A N S already exists, right? So first we check A exists, so we don't do anything. N exists, we don't do anything. D doesn't exist, so we add D, and as this is the end of the string, so we updated for the D that this is the end of the string here, right? So one of the string is ended here, right? Simple. Okay. Nothing complex, right? Simple. Okay. Now let's try to draw for these simple strings and do that. Okay. For the simple string, draw the trie. This will be the first root node, which is empty kind of, which have all the childs. Now, whoever is done, let me know. Just dictate it like what you are done. So we'll walk through it accordingly. Anyone want to help, like how to form the tree? Subra, you got it, like how to form the tree now?
Yes.
Okay, can you help me, like how we should add?
Yes, sir. So like we should we have and as the first string, so a doesn't exist, so we should add a also.
Okay.
Then we should go adding n and d, and
And
followed by d. And then since it's 10, we should mark end of file is equal to true, sir.
okay.
And then we should check for the presence of and, sir. So a exists, n exists, but t doesn't exist, sir. So we should add t
Okay.
and mark end of file as true.
Okay.
Then we should check for d. Since d doesn't exist, we should add d also.
Okay.
Then we should add o and then mark end of file as true.
Okay.
Then while checking d, we find that d already exists. So we should add a to the d.
Okay.
Then followed by d again.
Okay.
And then since it's then, we should mark end of file as true, sir.
Okay. And now if I want to search here, okay. Now if I want to search for does, how to do the search operation now?
We should start from the root node to d, sir.
Okay.
So D exists, and then O also exists. We find that O also exists while going for O. And then, sir, like we find that E doesn't exist after that, and we also check for the presence of end of file that is also there. So we should mark it as false so that it doesn't exist.
Doesn't exist. Okay. And now we want to search for now we want to search for Andaman. Okay. Then
We should start from root node to A. So A exists.
okay.
Then we check for N also exists. Then we go to D also exists. But then from there we find that there is end of file is equal to true and there is no A present. So we should mark it as false so that the string doesn't exist.
Okay. Now the last one. We want to search for DAD, right? Now
We start from root node to D. So D exists. Then we should go to A. A also exists. And then finally D also exists. So, and then we should check if end of file is equal to true or not. So that is also true. Then so we should mark it as true that it exists.
Right. So simply here we are get to know, like for each of the node, what are the requirements, what we need here, right? For each of the node, what is the structure that we can follow, right? So we need one thing, that is end of string is true or not, right? So if we try to draw for try, so one thing we need is a boolean flag which update, is it the end of string? Okay, so need one boolean to mark it end of string, right? And for all of the character, how many child nodes is possible? Any idea? Any guess from anyone? How many child nodes are possible here? See, for A, how many child nodes could be possible, right? Simply for this root node, A could be possible, B could be possible, C could be possible, D could be possible. Like how many child nodes could be possible for each of the any node?
26, Abid.
26, correct. Because we have a 26 alphabet, right? So 26 child nodes are possible. So here we can have a try array, okay, of kind of child, okay, where we could have how many childs? We can have 26 child, because there is only possibility of 26 childs. So this is the structure of a try, how we store the data in the try. Simple. So this is the structure of try. Now in case of insertion, so in case of insertion, what we were doing, we were checking for the root node, then we were checking for the next element. So here some value of I, right, whatever we want to store. If we try to do it here, just simple. So if you want to store answer, right, you created a root node already, so this is the root. Okay, now you check for first one. Okay, so here I is equal to 0. Okay, and this is level is equal to, this is some level. Okay, we check for this level whether A exists. No, A doesn't exist, so we mark A update A child. Okay, all the other childs are empty or null. Okay, so we update A is true, that it exists. Okay, now we go to I equal to 1. We check for I equal to 1 and its next level is this one. N exists. No, N doesn't exist, so we insert it. Similarly, we check for next level, S exists. No, S doesn't exist, so we insert it. Similarly, if we go for and, okay, then again we start with this root node. Okay, so initially start with I equal to 0. Okay, and current is equal to root. Simple, right? So this one. So now we will compare if this exists or not. Okay, if current dot child. Current is root, right? Its child. Which child? This ith position child, A. Okay. So consider you want to find the ASCII value, right? For because there could be 26 child, right? Now for A, we could store it at I equal to 0 child. For B, we can store it I equal to 1 child. Similarly, we can store at Z for I equal to 26. Okay. So similarly, if you see here for root, okay, there could be 26 possible of combination, right? So here we can store A, here we can store B, here we can store C, here we can store D, right? If you see here, we created a child array, right? We created a child array or an array of its child, okay? So there could be these possible options, right? G, H, and whatever, right? So this could be I equal to 0 in this child array. I equal to 0 could be at A, I equal to 1, I equal to 2, I equal to 3, right? So from A, if you want to get 0, so what you will do? You will just pick this character A, you will subtract A. So you will get the ASCII value as 0 because this will just subtracting the ASCII values, right? Similarly, if you do B minus A, what you will get? You will get I equal to 1 because the ASCII value of 50, like A is 57. If it is 57, then B will be 58. So you will get I equal to 1. Similarly, if you want to get the difference like E minus A, so what you will get? Something and then difference of 5 because it is whatever, if 57 then plus 5. So you will get the value of 5. So what you will do? You will go to the root child 5, child at index 5. Whether it exists, if it exists, it means it exists, we can move on to the next. If it doesn't exist, then we update it that it exists E. Okay, simple. So for this, if we have here, okay, so if we talk about it here, now we are at A, okay, and current is equal to root, okay, and the I we get I is equal to A minus A, which is equal to 0. So we check whether for this current, for this one, whether this 0 child exists or not. So we check if current of I, which child exists or not? 0 child. So if it doesn't exist, then we have to simply add it. Okay. If it doesn't exist, then simply add it, like update the child. Okay. Update that it exists. Okay. Because we are now doing the insertion here. Okay. So we will do the insert here. Okay. Simple. So what we will do, if it doesn't exist, then we'll create a current child, current of I. Okay. Or sorry, current dot child. I should be here. Okay. With child. Okay. Current dot ith child. We'll create a new node. Okay, so that means it exists, otherwise this node will be empty or null. Okay, so let's try to write the simple code, then I think you will be able to understand, will be easy to understand.
Arpit,
Yeah.
one small dot. Yeah, can we go to that 19th page?
Hmm.
Yeah, suppose in this particular tree, if we have to insert Andaman, so how it would be look like? Can you please draw?
Sure. Okay, keep yourself on unmute, Hemant.
Yeah, sure.
Okay, so now you want to start insert Andaman. Okay, so it's, I hope spelling is correct. Okay, now you start with the first one. Okay, so you start with the root node. Okay, initially you are at this level, you check its child whether A exists or not. Okay, A exists, correct?
Yeah.
So you move on to its child of A. Now for child of A, you are at this, you will check for this position. N exists or not?
Yeah.
Exists, correct?
Correct.
Okay. So you check for the next one. You check for D, whether D is the child of N.
Yeah.
Yeah. Okay. Now for A, we check for child of D, whether for D there is a child A.
Okay. No, there is no child.
No child, right? So we will add it here. So we'll add A child here. Okay. Now for this A, we will check whether M is the child.
No, M is not there.
So we will add M here. Now for M, we will check whether O is the child.
No, it's not.
Okay. For O, we check whether N is a child. Not right.
Yeah.
We'll add it. Now, once we had we processed all of the characters in this string, right? So we'll add that this is the end of one of the strings. So we'll update end is equal to true. So whenever we try to do the searching in the next time and we check for Andaman, so we'll ANDAMON and we search the complete string. And also one thing that we got here is that end is true. Something you want to search for and damn, I know that there is a no word called like this. Okay, but like, see, if you want to search for this word, so you check, okay, A exists, you check N exists, you check D exists, then you check A also exists, for M also exists, then you will say, okay, word exists. But if you see one thing, this is not the end of the word. Okay. This is not the end of the word. So you will say that this word doesn't exist because first, all of them should exist in the tree also. And we should also update whether end of the string is true or not. Then only we can be sure that, okay, this was the string where we have an end, because this could be a partial string also, right? Correct. So yeah.
So basically that end basically marks it as whether the string exists or not, right?
Exist or not. That is the end of like whatever tree we are doing now. So it means that there is a string which is ending at this.
Okay. Got it.
So if we have a m, end is equal to 2, it means there is a string that we inserted, where this string was there, a n d a m, where m was the end.
Okay. Yeah. Thanks, sir.
Okay.
Arpit, I have a question. If we had two strings like Andamon and Andam both in the dictionary, still while insertion, how do we mark them?
So if we have both, so we'll start with a n d a m, right? So we'll mark m is also equal to 2. Simple.
Okay, and when we are searching for Andamon, while we are going through, we will come across m as end of string, but we will stop there or we will continue
No,
searching?
we not stop there. There is no point of stopping there, right? So our first goal will be to check all of them, right? Whether all the character exist or not. Once we check all the character exist, then our next step would be verify whether end is true or not.
Okay.
Yeah. Okay. So let's try to write the code and let's see. Okay. So try is basically not much asked in it because this is very advanced DSA topic, right? So, but it's good to have a basic understanding like what is a try. So most of the people, most of the time you will see that they will not be asking you a question. They just want your understanding of the try only, right? Like you can be able to solve with the help of a try. So we'll solve basically one problem, which could be easily solved with the help of a TP. But at that moment, if you know that this could be also solved by the try, then it's good to explain to the interviewer. So that type of understanding I just want to build with this try data structure today. Okay. So the first thing that we have here is we create a class try. Okay, try node. Now what it have two things, right? So one is boolean, which is end of the word or not, is end of word, which is marked to end of the word or true or not. Okay, and the second thing is childs also, right? So what are the childs we have? We have 26 child, right? New try node. Okay, so let's create a constant here. Private int alphabet size 26. Okay, so now we created an alphabet size of 26 and then we have 26 characters here. Okay, so this is the structure of the try. Any doubt in this? Okay, so while initializing also, one thing we will do, we will fill all of these childs with an empty null value. Okay, so here we can create a constructor for this try node. Okay, and fill all of them with a empty or null value. So here you can array also, or you can use for